So consider this information. Suppose the number of students in an university or in a college or in a school are arranged based on ascending order of their marks. So this is the order in which the students have been arranged, and this is the lowest scoring student, and this is the highest scoring student. So that means that it is the ascending order. So then what is a percentile? Percentile is equal to n, means that n% of students have marks less than or equal to this particular student. So all the students that are up to this point, up to this point are n% of the total number of students. So using that concept, if you are able to pick the middle of this range, so what will be the percentage from starting to here? It will be 50%, and therefore this is 50 percentile, and which is also known as your median, and which is also known as the quartile 2. This quartile 1, quartile 2, and quartile 3 are just special cases of percentiles. Percentile 25 is known as quartile 1. What is 25? That means 25% of students having marks less than equal to this guy. Okay. Percentile is equal to 75 is known as quartile 3. So what is that? 75% of students have marks less than or equal to the marks of this person, this student. So this is the basic definition of percentile and quartile. Quartiles are always special cases of percentiles. 25 percentile is known as quartile 1, 50 percentile is known as quartile 2 or the median, and 75 percentile is known as quartile 3. So now another thing I want to discuss here, if you just count the number of students here, this is the 25. So we exactly have a midpoint here. So 12 students are towards this side and 12 students are towards this side, and this middle guy, this is the median student, and we actually have a true center of this data because we have a odd number of data. But suppose we have a even number of data, 24 say, then in the middle of that data you don't have any student. So then what to do? We don't have any median in that case. So in those cases we will create a dummy student here just in the middle and make this 25, and suppose this person has obtained marks equal to M12 and his mark is M13, and so marks of this person will be M12 plus M13 divided by 2. So this will be the median of the data. So therefore, whenever you are given odd number of samples, then the exact center will be the median. But if you are given a even number of samples, then always take the 2 observation at the middle and then take the average. That will be your median. So hope you have understood the percentile and quartile concept and the concept of median. So now let us see what do we mean by box plot. In a box plot only we will plot these things, and this in the box, the actually when we open the mini tab, box plot will be like vertical box plots. That is more common than what is shown here, horizontal. So in order to understand that, you have to rotate this clockwise to make it horizontal. So here it is horizontal. So the first line here, this is quartile 1, this is quartile 3. So in this case, this is quartile 1, this is quartile 3. The middle line is, this is your quartile 2, which is what? Which is the median. Then the end of this distribution or the line, these are the maximum and minimum for the box plot, and these are calculated by Q1 minus 1.5 into IQR. IQR stands for inter quartile range, and it is calculated as Q3 minus Q1. So basically this is equal to Q1 minus 1.5 into Q3 minus Q1, and therefore this is equal to, this should be plus, this is equal to Q3 plus 1.5 into Q3 minus Q1. And if we find some points outside this entire structure from here to here, this is the entire structure of the box plot. That means from here to here, if you look at it vertically, and any point outside this, irrespective of whether it is coming to the top side or the bottom side, that means towards the right side or the left side, these are called outliers. So how to interpret outliers? Outliers are something that is not supported by the underlying distributions, as if these points are not really coming from the actual distribution of this population. These are some kind of spatial cause variation for which these few data have been obtained. So the ideal process is remove these outliers. So remove this and also remove this, and then again construct the box plot until when all the outliers have been removed. So this is, suppose this is a box plot of stage 1 box plot. You remove this 4 outliers, then you get a stage 2 box plot. So here you had 4 outliers. Suppose in stage 2 you find one outlier again, so then you will remove that outlier also, and then construct a stage 3 box plot. Then you may get 0 outliers. Then you consider that stage 3 box plot to be the actual box plot, and then proceed all the descriptive statistic calculations based on that data only. So now come to the Minitab once again. So as you can remember, we had already found our histograms and descriptive statistics measures using the entire data sales, but we have not constructed the box plot. So first of all, I need to remind you the first job has to be constructing the box plot. Why? Because see, if I go to box plot and plot the sales, what do we get? We get the cells, which is fantastic because we don't have any outliers here. So all that we have done so far, descriptive statistics and histogram, are valid. Why? Because we don't have any outliers here, we don't have to remove anything. So now what? Now looking at the box plot, we can infer few things, but before that you can also create box plots using categories also. So suppose you are selecting with groups, sorry, not this one, box plot with groups, then sales, and category variables are days of week. Then you get multiple box plots like this. So what do you see here? So first of all, the Wednesday data has one outlier. It should have been removed. Anyway, I am not removing that. You can do it yourself. But what else is more important? You see here, this central line is a median. Median, 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 median. We can clearly see that the median of Tuesday is higher than this Friday, Monday, Thursday, Wednesday. This we can see. Another important aspect of box plot is you can determine the variability of the data and the skewness also. So if you find that the area to the top of the median is larger than the area to the bottom of the median, then it is a right skewed data. Exactly opposite is when the top side compared to the median is smaller than the bottom portion of the data, then it is a left skewed data. In this case, you see it is almost equal. So median is almost about at the center of the data. So top of the median and bottom of the median are almost equal. So therefore the skewness is not present. So the data is symmetrical. Here the data is right skewed because the top portion of the median is greater than the bottom portion. So it is right skewed. Similarly, this is left skewed. And if you just hover your mouse on the box plot, then it gives you the values also, like quartile 1, median, quartile 3, IQR, whiskers. What is whiskers? Whiskers are the top and bottom most point. These are known as whisker points. So for this, 102.68 is the bottommost point and 228.78 is the topmost point. Okay. So that's all about box plot. Now, the one thing that remains here is I have shown you the shape parameters in terms of kurtosis and skewness, but I have not discussed the values of the kurtosis and skewness coefficient in order to consider which one is what. So let us come to the slide once again. So if you can see here, when we are considering skewness, I have shown you these three diagrams in the last presentation or the last video, but I have not mentioned the ranges. So I am mentioning it here. If the range is range for what? Range for the skewness coefficient that is found in the descriptive statistic report. I will show that to you once again. So if that value is between minus 0.5 to plus 0.5, then it is a symmetrical distribution. If that is from plus 0.5 to plus 1, it is a right positive skewed or right skewed. Right skewed. If it is from minus 1 to minus 0.5, then it is left skewed or negative skewed. Similarly, for the kurtosis parameter, so if you check the kurtosis coefficient from the descriptive statistics report, if it is greater than plus 2, then it is leptokurtic. If it is lying between minus 2 and plus 2, then it is mesokurtic. And if it is less than minus 2, then it is platykurtic. So let us come to the Excel report once again. So as you can see here, the kurtosis coefficient is minus 0.57. This is in which range? Minus 2 to plus 2 range. So what do we tell you? If it is in minus 2 to plus 2 range, then it is a mesokartic. So that means it is not too much peak or too much flat. It is like medium. And what is skewness? Skewness is 0.05, 0.05 or 0.06. It is in which range? So this exactly lying in this range. So minus 0.5 to plus 0.5. So minus zero point 0.5 to plus zero point 0.5 in this range. So what type of data is this? Symmetrical distribution. So that is the reason when we were constructing box plot for the entire cells, you see the median is perfectly at the center, which means it is neither left skewed nor right skewed. Similarly, if you check the histogram of cells, this one, here also you are getting almost a symmetrical distribution, and also there is not too much peak is not obtained. So you can confirm these things using histograms and box plots also, and also using the kurtosis or symmetrical coefficient, sorry, skewness coefficients. So finally, these are the things I need to discuss in descriptive statistics. But in order to streamline the discussion little bit, at the end I will tell you how you should go about this. Means, suppose what kind of questions that can be asked in the entire statistics course. So you may be asked very simply the what is the mean of the population or what is the variance of the population. So remember central tendency, this is dispersion. We have discussed this in the last video. Or you may be asked compare the means between two or more populations, or compare the variance between two or more populations, or you may be asked the degree of association between two variables, or you may be asked whether the data is random, or what is the nature of the distribution for a particular population. These type of questions are to be asked in the entire statistics course. So not that you are going to answer them using descriptive statistics only, you must use the inferential statistics. But to start with, the starting point should always be the descriptive statistics. So what kind of reports you will use? So simply the descriptive statistics reports giving the mean value, mean, median, mode values. The report using the standard deviation and variance value, same report. These are the same report. The report that we generated using Excel in the first portion of this video. And then comparison between two population, means and standard deviation. These can be done using box plots and reports also. So if you can remember, we use multiple type of box plots for multiple days. So for example, the comparison between Monday and Tuesday can be done by the box plot of Monday and box plot of Tuesday. And the central tendency will be determined based on the median position, and the variance will be determined in terms of the size of the box plot. If the length is too wide, then the variance is much more compared to a box plot of having small length. And then the degree of association will be determined in terms of scatter plot. We have not discussed, so I will discuss this in a moment. Then whether the data is random or not will be discussed in terms of either scatter plot or time series plots. And then goodness of fit, whether it is following a distribution, normal distribution, it will be answered, not answered, I mean it will be judged, or a feel will be given, or a basic understanding will be obtained in terms of probability plots or histograms. Then it will be validated afterwards in using methods of inferential statistics. So now I have missed out this scatter plot and time series plot. So I will go to Minitab once again and show it to you. So in Minitab, you can go to graph and scatter plot and use this option. So suppose you want to check the relationship between the maximum daily temperature and the sales of soda. So you anticipate that when the daily temperature is more, the sales of soda is also higher. So in the x variable we will have maximum daily temperature, and in the y variable we will have sales of soda. So click on OK. and this type of plot is obtained. So what do you confer? Nothing. You may confer that the data is showing little bit of trendy nature, so it is not exactly at the center. So the theory is like this: if the data is forming increasing trend, like here, you may not see it readily, but there is an increasing trend, or there may be a decreasing trend also, not in this case but in some cases, or there is a complete randomness, that means the points are only clustered in a random way towards the center. So if that happens, then there is no association between these two variables. For example, if you just plot sales as the x variable and maybe not sales, suppose cookies sold as the x variable and chips as the y variable. So this, you cannot get any kind of trends here. It is completely unstructured and no particular trend can be understood, but in this case you see almost there is a trend. So you can use this line, you can see there is a straight line that can be used to determine the relationship. So almost it is a positive linear relationship, but in this case I don't think. You see the line is too flat here, there is no, this is the understanding you must imbibe, that if the line is flat, the trend line is flat enough, then there is no such relationship between the two variables. Okay, so now what is the time series plot? It is nothing different from the scatter plot. Only thing is, in the x variable, in the horizontal axis, instead of using any other variable, you are using time. So for example, graphs, time series plots, sales, and since the sales are already given in ascending time units, so this is your time series plot. So these are the dates. So we have not entered the dates because in the actual data the dates are already was in the ascending order using this t variable. So either use this time series plot or you can use the scatter plot also. This type of scatter plot using lines where your x variable is t and your y variable is sales, and then if you click on OK, you are almost going to get the same data. See, same data. This is your time series plot and this was your scatter plot, exactly same. So there is no basic difference, fundamental difference between scatter plot and time series plot. Only difference is in the x-axis or the horizontal axis we are using the time variable in case of time series plot. So why that is important? You see, if you want to see check the randomness, then you use the time series plots. So in the x-axis you plot the time variable and see whether the data is showing any random pattern or non-random pattern. So for example, in this case it is completely a random pattern. There is no pattern with respect to the cells that can be understood as a relationship. So that's all. I think the video is quite long now. I'm stopping this right now. I don't have anything else that in my mind that I need to discuss regarding the descriptive statistics. So let us wait for the next video in the next module which is going to the introduction of probability and distribution. Until then, thank you and thanks for watching this video.